Okay. So the first paper we are doing would be from the year. So we started studying from atomic structure, right? So we will do some questions related to atomic structure. The question 6 says, how many neutrons and electrons are there in gold 2 positive ions? Very simple question. I'm expecting answers from you guys, then I will explain. Number of protons are equals to the atomic number. The smaller number is always the atomic number. So the number of protons are 79. If had we be given the gold atom, the number of protons would have been equal to number of electrons, right? But right now we have a gold ion. So it has lost 2 electrons. So the number of electrons should be -2. 79 minus 2 would give you 77 electrons. And how do you find number of neutrons? You have to subtract the nucleon number and the proton number. 190 minus 79. So it becomes 111. So everyone is saying option A is your answer, right? It was a pretty simpler question. Let's move on to the other questions. Question number 8 says, which is the equation for the second ionization energy of element J? Yes. Answer, please. Option B. Because we have to form gaseous atom with the charge of 2 positive ion from J positive 1 gaseous ion by removing 1 mole of electrons. Nice. What about question number 9? Which is the reason why the fluorine has a higher first ionization energy than oxygen? If you see the periodic table, both fluorine and oxygen are from period 2. So period 2 elements, they start from lithium, then we have beryllium. You can see the periodic table, it will be given in the exam. After lithium, we have beryllium, boron, carbon, then nitrogen, oxygen, and fluorine. So he's saying why fluorine has a higher first ionization energy than oxygen. And we just studied it in the last class that across the period, values of first ionization energies increases, right? Okay. So fluorine must have a higher first ionization energy than oxygen. And the reason being because fluorine has a greater number of protons as compared to oxygen, but the number of shells or the number of quantum shells in oxygen atom and fluorine atom are same. Because if you see oxygen atom has 2 shells, fluorine atom also have 2 shells. So shielding effect is same, but number of protons are greater in the fluorine atom. So number of protons are greater. So the answer should be, we have to pick the number of protons because number of protons decides the nuclear charge. If nuclear charge is greater, the values of first ionization energy would be greater, right? So we have to see the number of protons. So fluorine atom has more protons. So the answer should be D. Is it clear to everyone? Five you said B, right? You got the answer now? Okay, let's move on. Question number 10 says, okay. Question number 10 says, what is the electronic configuration of chromium? Yes, that's a good one. We did the electronic configuration of D block elements separately. So chromium has an atomic number of 24. Where do we get the atomic number of chromium? It will be given in the periodic table. And the periodic tables are attached at the end of each paper. So you do not have to worry about everything. You do not have to remember these things, right? The chromium has an atomic number of 24. We can see it from the periodic table. So only Rayan has given the answer. Chromium's electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p6. We fill 4s orbital first, but after 4s is filled, it moves to the high energy level. Remember? And there was one exception in chromium and copper, that 4s of chromium and copper holds only one electron. So there won't be two electrons in the 4s subshell of copper and chromium. You have to remember that. So its 4s will have only one electron. And then we will have 3d. So up till 4s, we have added a total of 19 electrons. How many more electrons we still need to add? 5 electrons. But we would write its electronic configuration, final electronic configuration, as we will write 3d5 first, and then we're going to write 4s1. And the rest of the remaining orbitals before 3d will stay same. So if you see, they have given you the diagrams of the 3d subshell. 3d subshell has 5 orbitals. And they have given you the diagram of the 4s subshell. It has only one orbital. So if you have to fill 5 electrons in 3d, remember Hund's rule, the rules for filling the orbitals in a particular subshell, you have to fill each electron singly first. So it should be 1, 2, 3, 4, 5, and 4s has only one electron. So the right answer would be, and before 4s, all of these orbitals have the electronic configuration same as that of the argon. So instead of writing all the orbitals, we can just write the argon atom like this, because argon's atomic number is 18, right? So up till total 18 electrons, we can write argon, or we can use argon as a notation to just represent all of these orbitals before 4s. So the right option should be option C. Sarah and Ryan, Faik, and Rida. Is it clear now? Everyone, Sarah, is it clear? Whereas in copper and chromium is not filled completely. That was the exception that you need to remember. Got it? You have to remember this. And the reason behind why 4s is not taking up 2 electrons is actually not the part of our specification. We haven't studied the reason. But although we just discussed something about it, but you are not supposed to remember the reason. And the same thing happens with the copper element as well. So there are only 2 elements across the periodic table about which you have to remember that their 4s does not hold 2 electrons. And why do we call it AR? Because if you see the electronic configuration of the argon has an atomic number of 18. If you're going to make the electronic configuration of argon, it would be 1s2, 2s2, 2p6, 3s2, and 3p6. So up till 3p6, we know that we have added of total of 18 electrons. So chemists actually have devised a shorthand rule for writing electronic configuration, which is that if any atom has electronic configuration beyond 3p6, then up till 3p6, they can just represent the orbitals by writing the argon. Why they are choosing argon and not any other element? The reason being because it is a noble gas. That's why. So it's a shorthand rule to write the electronic configuration. I would suggest, if it is not written in your lectures, you should incorporate it in your class note, that it is a shorthand rule to make electronic configuration. Got it? Okay, moving on. Rest of the other questions are from different chapters. Let's see if we have any question from group 2. This is the okay, question number 24. Remember, we studied about the sizes of atoms or trend of atomic size across the period and down the group. Similarly, we studied about the ionic size across the period and down the group. And particularly, we were discussing about the group period 3 elements. Let me just give you a recap of it. Then we will move on to this question. It's a very good question, actually. So if you just recall this thing, that across the period, atomic size always decreases. And the reason behind it is that because across the period, number of protons increases, but number of shells stays same. So shielding effect stays same. So what happens? The electronic shells, they move closer to the nucleus when number of protons increases. So across the period, size of atom decreases. Down the group, it increases. But if you see the trend of ionic radius across the period, from sodium to aluminum, because these atoms form positively charged ion and they lose electrons. And when they lose electrons, their shell decreases. Number of shells decreases because they have, if aluminum atom has 3 electrons in its valence shell, when it's gonna lose those 3 electrons, there will be no shell left or no third shell left. The aluminum ion is left with only 2 shells. So if we see the trend of ionic radius across the period up till aluminum, or let's say silicon, if we are considering that silicon is forming a positive charge, then number of shells decreases as the ions are formed. So their ionic radius should decrease and they should be smaller than their corresponding atomic radius. But as we compare from phosphorus to chlorine, because these atoms, they gain electron to form an ion. So it means their number of shells are not decreased. In fact, when extra electron is added, the repulsion between the electrons are increasing. So the electrons, they move slightly away from each other due to the repulsion. And the size of ion is slightly greater than as compared to the size of their corresponding atom. But across the period, the size of ions also keeps on decreasing. So this question is about ionic sizes, and he is asking you to plot a graph of the data. And they have given you x-axis and y-axis. On y-axis, they haven't given you any scale. You have to decide the scale by yourself. Do you guys know how to plot graphs? Every graph has x-axis and y-axis. And then you have to see the minimum value that you need to draw on y-axis and the maximum value that you need to draw on the y-axis. But just by judging these values, you can set the scale of a graph. Once you know the scale of a graph, you can start plotting the coordinates. So if we see the smallest value that we have is 54 and the largest value that we have is 171. So the largest value on the y-axis should be greater than 171. Let's say if we can make it 200 or 180, that depends. And the smallest value that we have is 54. So we have to start our graph either from 0, or we can also start from any value lesser than 54, that can be 50 as well. No, you are not supposed to fill the size of Mg2 positive ion. When you're gonna make the trend, then he will ask you the size of the magnesium ion from the graph. Because you know magnesium ion is over here, Mg2 positive ion. When you have drawn the graph, the shape of the graph, then after plotting the line, you will have to read the size of the magnesium ion. If he asks in the question, and obviously he will ask this. First you have to draw the graph. And it's for 2 marks. So let's, if you have to take the maximum value greater than 170, so it would be better if we start from 0. It's better to always make graph using a pencil. Let's say if we start from 0 and if we give every box a value of 10, and the radius is given in the unit pm. Pm is basically picometer. This is picometer. You know the suffixes or prefixes of dimensions? Like after meter, what comes after meter comes decimeter. After decimeter, the smaller unit than decimeter is centimeter, then millimeter, then comes micrometer, then comes nanometer, and even smaller than nanometer is picometer. So the size of the atoms or ions are so small that we have to measure their dimensions in terms of picometer. But anyhow, unit is given, so you just have to label the axis. Always label the axis. If axis is not already labeled, you have to label the axis. You are going to plot ionic radius, and after writing the name of the quantity, you have to also write the unit. The unit is given in picometer, so you just make a line after radius and write the unit. It has to be picometer, right? So if we take the initial value as 0, then 10, then 20, then 40, then 50, then we cannot just reach more than 170. So we cannot take these values. It would be better if we are taking 0, or if we take with the gap of 20, it should be 40, 60, then 80, then 60, 80, then 100. After 100, it would be 120 and 140 and 160. But we have to incorporate the value of 171. It means if we are starting from 0, it won't be possible. Do we need to start the graph from 0? Is it always mandatory that we can all just start the axis from the 0 value always? No, I haven't written anything. I was just giving you the idea that whenever you have to plot a graph, you have to incorporate the smallest value as well as the largest value. So you have to set up the scale in that way. Yes, if we start from 40, that would be more better. If we can start from 50, and 54 can be easily incorporated in it. How about if we start from 40? Or let's say if we start from 20, 40, then 60, 80, 100, 120, 140. After 140, we have 160 and 180. So yes, 171 value will be incorporated in it. And also the 54 value will be incorporated in it. See guys, you could have also taken it like this. For example, if our graph is like this, and let's say if you had started from 50, or you could just have taken one small box is equals to 10 units. You could have just written 100. Like you could have written just 50, 100, 150, and then 200. So everything would have been incorporated in this value. But you cannot take the scale like this, because whenever you have to plot a graph, you have to make sure at least more than half of a grid is covered. Whenever you have to plot a graph, you have to stretch it to an extent that when you plot a line, half of a grid, more than half of a grid should be covered. It's better if the full grid is covered. It is acceptable if more than half of a grid is covered, but it is not acceptable if less than half of a grid is covered. Getting my point? I hope you guys have been practicing making graphs back in your grade 11 in mathematics and physics and chemistry. Not maybe particularly in chemistry in grade 11, but as far as I can recall, your physics, your maths, they include graph. And obviously in Edexcel-A level, in mathematics also they may give you to plot the graphs, physics as well. Here we have graphs in chemistry as well. So should we start plotting the values? For nitridine, it is minus 171. So we have, if you see these 10 boxes from 160 to 180, we have 10 small boxes. So 171 should have been over here. If we see one box is equals to 1 unit. See, 172, 174, 76, 78. If we need to plot 171, so 171 should be somewhere in between the box of 170 and here should be 171, right? It should be in between 170 and 170, sorry. This one has to be 172. So 171 should be in between this value, like between 170 and 172. Got it? For oxide ion, it has to be 140. So you can directly plot the value 140 over here. For fluoride ion, it is 133. So we can see 120, 130, 132, 134. It should be between 132 and 133. For neon, for neon is not given. Why for neon is not given? Because we have established that for noble gases like argon and neon and krypton, we do not include them while studying the atomic radius trends. The reason behind it, because we still cannot measure their atomic radius accurately. For sodium ion, it is given as 102. So after 100, one small box after 100 should be 102. For magnesium ion, it is not given. For aluminum ion, it is 54. So 54, 54. So this is the scatter of the points that we are getting. Then we have to plot a graph of the data. If you see, we just cannot join all of these points with a straight line. The reason being because these points are randomly scattered. If you recall, we are actually supposed to make a best fit line. Yes, very good data. We are supposed to make a best fit line. And what is the best fit line? Best fit line is the line on which most of the points will lie. Some of the points may not lie. Some of the points are going way out of the trend for as compared to the other points. So we have to manage to make a best fit line. And if any of the points are left, are not coming on the best fit line, will be considered to be anomalous point. But we have to try our best that all the points should lie on the line. But in no way I cannot make a graph like this. Like if I just try to join all the lines, that won't be a line. So we have to make a line in such a way that if any of the points which are not coming over the line, they should have an equal scatter. What does I mean by that? That if we are drawing the line, the points which are not on the line. So if there are, let's say, 1 point above that line, so there should be another point below the line. For example, if I just try to draw the line of best fit, including these points, the line should be something like this. So two of the points, or let me just, this has to be your best fit line. So some of the points are not over the line, some of the points which are not over the line, they are close to the line. So yeah, but I won't call it a best fit line because I do not have a rule in my app to make a best fit line. But let me just try it again. What I'm trying to do is the number of points that are above my line, which are not included on the line, should be equal to the number of points that are below my line. So I have to draw the line in such a way. This is the best way I can draw it, because if you have a rule with you guys, and I would recommend that if you can take a printout of it, or if you have a piece of graph paper, you should try making this at your home. Anyways, moving on. Is it clear up till now? Is everything clear? Rayan, Rida, Faik, and Sarah. Okay. So in the second part, he is asking predict the radius of the magnesium ion using a straight line of best fit on your graph. So how would you read the radius of the magnesium ion? You will make construction line. These are known as construction line. You have to draw this line as dotted lines and do everything with the pencil, okay? Do not use pen over the graph. You have to read out the ionic radius from here. So it is coming out to be 71 picometer. And in the exam, you will be given the range. You are allowed to write in the, if you, let's say if someone has written 72, that answer is acceptable too. Because in the marking key, he would give you a acceptable range because everyone's line would be slightly different. If you're going to make a base fit line, there will always be a slight difference between the line of all of you guys. So when you're going to read the value from the y-axis, that would be slightly different from everyone, for each and every one of you. It means in the marking key, he won't just give you one discrete value until or unless he has just given you the graph plotted by himself. Then only he can just give you a discrete value that you have to select. Your answer should be this value. Otherwise, whenever he asks you to make a graph by yourself, then he just leaves you the margin of error. Let's say if Rida has drawn the basket line slightly tilted, or if Rayan has not just drawn these basket line in this way, there must be a slight difference between your final answer. And in the exam for this particular question, he has given you the value from 70 to 80 picometer. Any candidate who has found the radius in between 70 to 80 picometer, that is acceptable. So if we read our ionic radius, it is coming out to be 71 picometer. And this is acceptable answer. You just have to write 71. Make sure you also write the unit with the radius because the unit is given in the table. The unit for radius is picometer in this example. Now he is asking you to explain the trend in the ionic radii from the nitride ion to the aluminum ion. From nitride ion to the aluminum ion, the ionic radius are decreasing because if you see nitride ion has two shells. Because all of these, if you see from nitride ion, it is 2,8. After gaining 3 electron, oxide ion is 2,8, fluoride ion is 2,8. Neon atom, we are not discussing the radius of the neon atom. For sodium ion, again it has two shells because sodium ion has lost one electron. Sodium atom had 3 shells, but after sodium ion has lost one electron, it will form plus one ion. And the magnesium ion also have lost 2 electrons from its valence shell, so now it is left with 2 shells. Aluminum ion has lost 3 electrons from its valence shell. See, they haven't started this ionic radius trend from the leftmost element of the periodic table. They have started it from group 15, group 15, group 16, group 17. And then first they discuss about the nitride radius, then oxide, then fluoride. After fluoride, neon is not coming under discussion because we know that we cannot measure its radius accurately. After that, they have directly moved towards the group 1, but in the period below period 2, which has to be period 3. So sodium ion, then as we move beyond sodium ion, it has to be magnesium 2 positive ion. And then group 13, which is aluminum ion. But as the ions from group 15 to group 17 are negatively charged ions, so there is no decrease in the shell. But as we see the ions from group 1 till group 13, they form positively charged ions, so there is a decrease in the shell. So now all the ions from period 3 that are forming the positively charged ions, they are left with 2 shells. And all the ions of period 2 from group 15 to group 17, they are gaining electron. So they already had 2 shells and now they will be left with 2 shells. But when we see the trend of these ionic radius, still the trend is decreasing trend. While fluoride ion atomic radius is smaller than or it is larger than sodium ion. Why sodium ion is smaller than fluoride ion? Because both of these ions have two shells, but the sodium ion has greater number of protons. If they have same number of shells, it means they have same shielding effect. But sodium ion has greater number of protons, so its nuclear charge is greater. So naturally, if number of protons are greater or nuclear charge is greater and shielding effect is same, so it means the size of that particular ion should be smaller than its preceding ion. There is fluoride ion in this case. You getting my point? How would you write the answer for this question? I need you to give me the points that we have discussed. First, you have to establish whether the ionic radius is decreasing or increasing. So that you can clearly see from the periodic table, from nitride ion to aluminum ion, the ionic radius is decreasing. So once you know the trend, you will earn 1 mark just for that. Ionic radius is decreasing. Very good. You can say ionic radii. It's better if you write the word radii because we are talking about multiple radius of different ions. Ionic radii decreases from nitride ion to aluminum ion. This will earn you 1 mark. Why is it decreasing? Because number of protons are increasing, which increases the nuclear attraction, or you can write nuclear charge. But number of electrons, what we're gonna write further, but number of shells in all of these ions are same. So shielding effect is same. Got it? This is the answer for 3 marks. The first mark you're gonna earn just by identifying the trend that the radii are decreasing. This will earn you 1 mark. And the number of protons are increasing across these ions. This will earn you another mark. Whenever you are doing theory questions, make sure you know how many marks you are getting for which point. And as number of shells are same, so shielding effect stays same. If you have written this thing, then again, for this point, you will earn 1 mark. So that's how you will end up getting 3 marks in total for this question. Got it? Rehan, Faik, Sarah. Should we move on? Okay. Okay, whenever you see the word isoelectronic, it's better if you just incorporate this in your lectures. Isoelectronic means anything having same number of electrons. The word Iso-electronic means same number of electrons. So he was asking which of these isoelectronic ions has the smallest ionic radius. Anything that has if it has same number of electrons, it means they must have same shells. If they have same number of shells, it means they have same shielding effect. So the only factor that should be different, that can decrease their atomic size or ionic size, should be the number of protons. So which of these ions has more number of protons will have the smaller ionic size. That's it. What should be the answer? Nitride comes from nitrogen, which is an atomic number of 7, then 9, sodium 11, aluminum 13. Got it? Easy, right? Very easy. And yep. Question number 20 is complete the electronic configuration of copper atom and copper 2 positive ion. So you have to recall that exception that was there in chromium. It is still there in copper as well. And you have to start making the electronic configuration from argon. It means up till argon, you would have already added 18 electrons. You have to carry on after argon. I mean, if you just see argon atom, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. That is up till argon. Now, if you have to go beyond 3p6, there comes 4s2 and 3d. But while making the electronic configuration of copper, you have to realize that its 4s subshell holds only one electron. So rest of the other remaining electrons should come into 3d. And how many electrons are there in the copper atom? Copper has an atomic number of 29. It means a copper atom has 29 protons as well as 29 electrons. So up till 3p6, you have added a total of 18 electrons. And the 4s of copper only holds one electron. This is the exception that you need to remember for copper as well as for chromium. So 4s of copper holds only one electron. And the rest of the other remaining electrons, they have to go in 3d. So 3d will hold 10 electrons. But you won't write the electronic configuration in this way. You know that 4s once filled, it moves to the high energy level and 3d moves to the lower energy level. So you have to write 3d10 before 4s1. But up till 3p6, you are not supposed to write the electronic configuration because they have already written argon in that place. It means up till 3p6, they have already incorporated everything. After argon, you know that there will come 4s1 and 3d10. So this is the shorthand rule for writing the electronic configuration of a copper atom. But the next part says to write the electronic configuration of a copper 2 positive ion. It means you have to remove 2 electrons from the copper 2 positive ion. So from which orbital or which subshell you're going to remove the electron? That's the trickier part. From which orbital should we remove the electron? The orbital which is the 4s or the orbital which is a 3d? Why from 3d, Rida? And it's better if you just write the electronic configuration of atom in the final order. Like we know that 4s moves to the high energy level and 3d moves to the low energy level. So if you just write it like this is more appropriate. I would recommend always write it like this. The other one is also acceptable too, but it's better if you just write 4s after 3D, because when you have to make the electronic configuration of a 9, you should be able to realize that the electrons that are present at the highest energy level are the first ones to be removed. Rather, that thing what you are saying is basically for the electrons that you are removing from the same subshell. Let's say, just forget about this question for a while. Let's say if I have any atom whose outermost subshell have these electrons filled 1, 2, 3, 4, 5, 6, and 7. So this is the seventh electron. Let's say the one that I am drawing in the right color is the last one to be filled. So if you have to decide in between the electrons of the same subshell, that would be the electron that is filled in the last, because all the electrons in the same subshell are at the same energy level. So how would you decide which electron would be removed first? Always remember one thing. It's better if you keep taking notes along with it. See, the electrons in the final electronic configuration, which are at the highest energy level, are first to be removed. And how would you know which electrons are at the highest energy level? Because the electrons which are in the orbitals that are written in the last. Because the way we have written the order of the orbital is as per the energy level. So the lowest energy orbitals are written first, then the high energy orbital, then the high energy orbital. And when we are saying that after you have filled 4s and 3d of copper, 4s of d block element or 4f of any other element of the periodic table, after once you have filled 4s and after that if you have filled 3d, 4s always moves to the high energy level than 3d, right? So it means the last orbital or the orbital with the highest energy level is 4s. So when you're going to remove the electrons from any atom, you have to remove the electron that are present at the highest energy level. So 4s is at the highest energy level. So if you are going to remove the electron, the first electron that you will remove should be from 4s1. And this would give you copper plus 1 ion. But now, once you have removed one electron from 4s1, it means the other electron that you need to remove should be from 3d, and 3d has 10 electrons. So which electron would be the first one to be removed from 3d? Now, if you are comparing the electron in between the subshell, so the subshell that is at the high energy level, its electron will be removed first. And how would you know which subshell is at the highest energy level? The subshell that is written in the last. In case of copper, 4s will be written in the last because it will always move to the high energy level once it is filled, because it was filled before 3d, but after the electrons are filled, it moves to the high energy level, right? Yes. So after you have removed one electron from 4s, you still need to remove one more electron because you have to form copper 2 positive ion. So in 3d, we have total of 10 electrons. If we start filling 3D, you would have filled 3D in this way. 1, because you had to fill each subshell singly first. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in the same subshell, if you have to decide which electron will be removed first from all the orbitals of the same subshell, and how would you decide it? The electron which is last to be filled or which is filled in the last will be the first one to be removed. So which of these electrons out of these total 10 electrons is filled in the last? The one that I have drawn in the black color, right? So it means this electron will be removed first from 3D. Then after that, if you need to remove further more electron, that would be this electron. Then this would be this electron, then this electron, then this electron. And after that, it should be again this electron. Then you will just, if you are filling from left to right, you fill singly first, then you fill pairing from left to right. If you have to remove, you will go from right to left. You will remove one electron from each orbital from right to left. And once you are done removing one electron, then again you will start from right to left. So 3D, from 3D you will remove one electron and you will be left with 3D9. That's it. So that would be the electronic configuration of copper 2 positive ion. Rayan, Aisha, were you there in the class since they start? Faik, Sarah. Yes, you guys need to confirm if you guys have understood it or not, because this was a trickier question and most of the students, they lose marks in this question. What about you, Faik, Sarah, and Aisha? I think Aisha has been forced to take the class. What about part B? A sample of copper contains, okay, we haven't studied that yet. So in the next class, we will be done with this chapter. And in fact, we going to start another chapter next week. So we'll be done with chapter 1. And now we will increase our pace, because so far, as we have just started studying chemistry, we were taking the sort of introduction of Edexcel or A-level chemistry. So we have been taking it slow. But now we will pace up. We will speed up everything. Okay, Aisha, why you are having clashes? How is it possible? If we have said, why you said okay to this time then? Or is it just like a clash on in these days, or would it be a regular clash? Okay, got it. Okay, only today and yesterday. Then that would be okay. Okay, you guys need to tell me, do you guys have any sort of like